And people will most likely just start jumping in as we get going. So. Ugh. All right, everyone. Hello. Thank you for joining us again today. My name is Kara Gordon. I am the Partnership and Communications Coordinator for ECU's Center for Sustainable Energy and Environmental Engineering. I'd like to welcome everyone today to our first webinar of 2022 on industrial decarbonization. Our mission here at the center is to promote renewable energy technology and natural resource conservation through scholarly and applied research, an effort to enhance industry awareness and best serve North Carolina communities. With research funding through the EPA's Pollution Prevention Program and Source Reduction Assistance Programs, center students and faculty and affiliates provide valuable resources to businesses and industries across North Carolina. We offer energy, P2, and lean assessments and training, largely to North Carolina automotive, chemical, fabrication, and food and beverage manufacturers. And after conducting a facility assessment, the center additionally provides technical feedback and various business analyses. We also facilitate certification workshops like Lean Six Sigma for sustainable green manufacturing. Pardon me a second while I let everybody in. For some reason, it's not. Hang on. Okay. Sorry about that. Okay, so before I introduce today's speaker, just a little bit of housekeeping. We're recording today's event. Access to the event recording will be provided by email after today's webinar. We encourage you to interact with our speaker. We'll take questions at the conclusion of the presentation, or you can drop them into the chat box at any time and I will address them at the end. In the follow-up email, I will also provide a link for feedback. If you could give us just a moment of your time and tell us how we can improve our future events, that would be fantastic. And then finally, the email will also provide a link for donating to the center, or you can just simply go to give.ecu.edu/CSE3 at any time. And we gratefully appreciate any contribution as it helps us support student activities and community engagement. So I would like to introduce today to you Daniel Wilson. He is the Vice President of Wilson Engineering Services, which provides a suite of services focused on process optimization, energy efficiency and renewable energy, carbon accounting, and decarbonization across all scopes of greenhouse gas emissions. Dan has overseen WES's role in over 200 decarbonization, renewable energy, and low carbon energy projects. His role in these projects has included concept development, feasibility studies, business and finance planning, design, permitting, construction management, commissioning, and operations. Prior to co-founding Wilson Engineering Services in 2008, Dan was an engineering project manager at Goggin, Goggin and Pride Associates, excuse me. Dan is a registered professional engineer and holds a BS in agricultural and biological engineering from Penn State and a master's in civil engineering from Johns Hopkins University. So thank you, Dan, so much for your time and your expertise today. I will turn the platform over to you.
Well, thanks so much, Kara, and thanks to everybody for joining the call today and giving me the chance to talk about decarbonization. So, Kara, can you confirm you can see the presentation?
Not yet.
Oh, I probably did the share wrong. Hold on one second while I get myself in order here. Let's see. All right, I think that should have done it there.
Yep. There you are.
Okay, no, and I appreciate everybody joining the call today to talk about industrial decarbonization. Before I get started, I do want to take just a couple seconds to identify who our companies are and what our background is a little bit to give you some context of our experience. And then I'll give you an overview of the presentation itself and then dive right into things. So we have an ownership group that has two companies. One is an engineering company and one is an energy and decarbonization services company. So engineering company has been around since 2008 and has worked in decarbonization really since then and has worked across a bunch of different industries and as well as types of projects on design and engineering services. And then the energy and decarbonization services company has been in existence since 2013 and really focuses on energy and renewable energy consulting and monetizing renewable energy attributes from projects like REC aggregation and as well as carbon accounting. So those are our companies, and our experience is pretty broad and pretty varied. We've worked on quite a number of different types of energy projects and decarbonization projects in general. We've worked across a lot, like I said, a lot of different industries. So we have a pretty broad experience, and we don't represent equipment or anything like that. So we're completely agnostic on types of technologies, and really our job is to help folks find the best option for them as they go about their process of decarbonization when we're doing that work. So that's a little bit about us and our background. Now, a quick outline of the presentation. I'm going to start by getting into very briefly the emission scopes so everybody's on the same page with that and why it might matter to a business. I'll spend the bulk of the time on the presentation talking about thoughts about how you would decarbonize. Scope 1 is what I'll focus on mostly because that's kind of the hardest for an industrial facility usually to decarbonize. But Scope 2 as well a little bit. And at the end, I'll get into some tips or thoughts we have, having done this for a while, some thoughts that you might find valuable as you go about your process of decarbonizing your facility. So just very briefly on the scopes themselves. Scope 1 emissions are direct emissions by your business at a facility that you control. And so a real easy one to conceptualize here would be natural gas boiler. The emissions out of the stack from that at your facility that you own are ones that fall into Scope 1. Scope 2 is indirect emissions from energy purchases, usually going to be electricity. And so a real obvious one there is you purchase electricity from the grid and there's a power plant somewhere else that someone else controls that's emitting. You have to own part of that, part of those emissions. And then Scope 3 is upstream and downstream of your business. So think supply chain and distribution of products. And again, I'm going to focus mostly on Scope 1 and a little bit on Scope 2 today. Now, why might this matter to your business? There's a lot of things we could talk about for why this matters, but the bottom line is economics. And this has really changed over the last 5 years. We've seen it change quite a bit. And actually in the last 2 years, we've seen it accelerate where your customers possibly are requiring you to report to the CDP, or there are other pressures from customers for why you would want to be reporting or making goals. Also, access to capital is starting to be impacted by reporting or goal setting. So there's a lot of reasons why you might want to do this, from general responsibility perspectives and other things, but it all comes down to economics is really the big driver, which is why folks are probably here. If you're just getting into this world, it can be a little bit daunting to start out with trying to figure out who you report to, why you report, what you report, and what goals you can set, what the rules are of the road for how you do all this. I'm not going to spend hardly any time or any time at all talking about that today. You could spend, we could have a whole presentation on that. But one thing I will say is that if you're just starting out, start with the Greenhouse Gas Protocol and the corporate standard. That's a pretty great place to go. Check out their information. That'll get you down the path to getting things going and to understanding what you're doing in that world. Now, that is extremely important because that establishes what your rules are and what you're trying to do, essentially. But once you've gotten through that, and even as you're going through that, establishing goals and reporting, you still have to produce your product. And once your goals are set, you have to make your product, and you have to do this now while reducing greenhouse gas emissions and meeting your goals. And oh, by the way, probably they're going to make you say you got to save money while you're doing it. And that is that possible? Number one. Number two, how is that possible? And so that's what I'm going to focus on today, is mostly how you might think about approaching decarbonization. So we could use a lot of different excuse me, metaphors to kind of describe this. I think a good one might be that this is a marathon, not a sprint. You're going to be, if you're looking at decarbonization, you're going to need to go through a process that's pretty thoughtful and purposeful in the end. And that's a key takeaway from this presentation, is that you're going to, it's a fair amount of work. And if you want to do it in a way that doesn't cost a lot of money, that's even more work. And so the typical process is you have some strategic planning that you're doing as a company for why you're doing this and how you define your goals. And you're going to be also, the key first step is really benchmarking your organization and where you are in terms of emissions and energy use. And if you want to be able to do this cost effectively, you really need to be gathering a lot of data on your energy use in terms of sub-metering and the processes that you have at your facility and how they work. There's quite a bit of data involved in doing this well, I believe. And then once you have that data, you can analyze options for your facility and develop solutions to help you decarbonize. And then you can implement the ones that make sense. And you're gonna kind of iteratively do this. So you're gonna implement some projects. You're gonna see how that impacts facilities that you're working at, and then you're gonna apply that knowledge to goal setting and what your targets are and how those are changing over time. So it's gonna be an iterative process that we expect you to go through. And one of the reasons it's good to set this up ahead up front as you're getting into it is you can do a lot of great energy projects at your facilities. So let's take, what would be a good one? Like compressors for compressed air, like upgrading those to save energy. That's kind of an obvious first one that you might target. And you can work with vendors to go ahead and implement that type of project, and that's a great project, and it'll be obvious why you would do that for economic reasons and greenhouse gas reasons. But if you're setting up your facility with an overall plan, you might understand that, hey, I want to heat, as part of our process, we heat some air that's coming into the facility over here. So a good project might be to capture heat from your compressors and use that to heat that incoming air. Well, if you've done your compressor project not knowing that you had this other opportunity, maybe that's set up in a way that's not as easy to capture that heat later. So there's a good reason to kind of do this in a thoughtful way, because it can open up windows of opportunity for you as you go about your process. So I'm going to spend just a little bit of time talking about metering and tracking things, because that is our first step that you have when you're trying to decarbonize. And if you look at your energy bills in general, most people have already been doing this, but if you're tracking your energy well in terms of your gas purchases and your electric purchases, and if you have smart meters, even on your gas systems and electric systems, you can see how your energy draw varies over time and glean a lot of information from that. But if you're going to decarbonize a facility, typically you've got to go beyond that and actually do metering on your processes, key energy users, sub-metering. You probably want to monitor any exhaust that you have from the facility, what quality heat is leaving and how much. there's probably a lot of tracking of things that you want to do. And there's a lot of facilities that are pretty far down the road, or maybe not so far down the road in this kind of tracking process already because they want to optimize their processes. A lot of things that we see at facilities when we go into them are that they collect data in a bunch of different ways. So we'll go into facilities that have really great manufacturing equipment that already collects quite a bit of data. Sometimes, though, they don't actually have access to it other than to view it occasionally. So that's something you can clean up and usually get that data out. We see a lot of facilities that do some tracking, but mostly it's monitoring based, and they're not actually keeping the data. So they might store it for 7 days, a month, but then it gets dumped. So that's something that you can clean up fairly quickly. Another thing that we find is that a lot of times the data we get out of the systems where they're tracking information now maybe is hard to interpret because there's no tie to what the points actually are, or no, people aren't really sure which points which. Some of the units are tough to figure out, those types of things. So you really need the data to be in a useful format, in a way that you can use it easily to analyze trends and figure out how you can optimize things, not just for decarbonization, but also for your facility. There's usually a lot of benefits you can get in your processes if you're doing that. It's pretty interesting. We go to a lot of facilities, and there'll be maybe one guy who knows how to get some of the data, and they're on vacation usually when we show up somehow. And then there's other folks aren't quite sure what they actually track, but they can probably tell us when the guy gets back. That is not a problem mostly for folks how they run their facilities now, if you're working that way. But if you really want to decarbonize that, that kind of thinking process in terms of how valuable that data is something we would suggest thinking pretty hard about. We've shown up enough and run into those types of situations that we have developed our own kind of data tracking system to help people with this. We have used this with our own clients for quite a while, and then we realized maybe we should sell it. But it's essentially a box on a wall that has a computer in it that pulls in data from a bunch of different formats, puts it to our cloud, and then we provide it back to the facility in a way that's easy to manage and analyze for them. That is metering in general. Just some quick thoughts on that. And again, that is a really key aspect, and you really need a metering plan for your facility, most likely if you're going to try and really tackle decarbonization. Now I want to get into Scope 1 emissions and how you might think about reducing that. The thing about Scope 1 is typically those are going to be, not every facility. You might have a fleet that you own and control, and that might be a pretty big source for you. But a lot of times this is thermal energy at a facility that we're talking about is your Scope 1 emission. And the reason I'm focusing on this in the presentation mostly is that this is really the hardest one we see for industry to really tackle in a cost-effective way or in a holistic way. When you purchase your energy to serve your thermal needs, you have a lot of choices. And I've listed some of the choices here in terms of very typical dollars per million BTUs of delivered heat into the facility. And so this is after considering efficiencies of equipment, things like that. So I've also shown, just for fun, down here what the greenhouse gas emissions are associated with each one of those. This is for electric resistance for North Carolina's grid. This is what the emissions are per million BTU of heat if you're doing electric resistance. So this is just some general information on basic options you have. And obviously you want to use these options. These are the cheap ones down here. And one thing you'll notice about all these options is something we'll talk about here is that they're quite temperature dependent. And I'm going to spend a lot of time talking about that. The only one that's not is really maybe forest industry residue. If you haven't looked at this as an option for decarbonizing your facility, that's something you should really look into, and I'll talk a little bit about that. But most of these down here that are lower cost have an issue associated with them, and that is they can really only serve a certain temperature profile for a facility. So if you hear about electrification of thermal loads, that can be a really good opportunity for a lot of facilities. But we like to use the term beneficial electrification or something like that, because not all electrification is good electrification. Right now, if you were to take electric resistance, convert your natural gas use for high temperatures, and use electric resistance in North Carolina from the grid to do that, you would be emitting more carbon by almost double, not quite double, per million BTUs. So maybe you don't want to do that just yet. So there's a lot of opportunities that you need to look at in in kind of an in-depth way to figure out what your options might be and how they stack up. Again, the lower cost ones tend to be some of the ones that also have this temperature limitation. So here we're showing kind of the temperature you can expect to go up to an industry with each of these technologies. And this is not a fully comprehensive list, but most of the lower cost ones also have this temperature limitation. Again, the exception being forest industry, biomass type projects, ag waste projects, or anaerobic digesters if you have a bio waste that you're trying to get rid of anyway. I'm going to spend quite a bit of time talking about temperature now and how it impacts Scope 1 and some ways that you might think about it and approach it for your facility to help drive decarbonization. Now, if you look at temperature across all manufacturing in the entire US, around 30% of thermal demands that we meet in manufacturing in the country don't require anything more than 212 degrees. But a lot of the facilities that we work in, folks are meeting these needs with the same lower temperature needs, with the same steam that they have, or other process heat source that they have that's really maybe 400 degrees, something like that. And that's not a problem. In fact, there's a lot of good reasons to do that. But if you're trying to decarbonize, we're going to show you why maybe that something to rethink. And here are some other industries. This data is getting a little bit old, but it probably hasn't changed much. You can see some industries that tend to have bigger portions of their energy demands able to be served by lower temperature energy sources. So to kind of get at this, our company does what we call a heat stack analysis. And this is where we stack up all the heat flows in a facility by temperature. And so the green here, let's see, we're looking at this facility. The green here is 300 degrees Fahrenheit, and this is boiler steam, and all the energy demands in this facility are met with boiler steam, it looks like. And so we have 300 degrees Fahrenheit, so that's probably 50 pounds saturated steam is about what that is. In the red, we're tracking what the waste heat is leaving the facility and at what temperature that is leaving the facility. And then we have a little bit of cooling demand at this facility as well. So looking at it from what can we serve with lower temperatures? Do we actually need 300 degree steam to actually serve the thermal demands in this facility? If we dive into the processes, track things a little bit, and look at actual temperatures, mass flows, we can figure out that, well, we can segment out 25% of the total energy in this facility. We can meet with a temperature that's lower than 300 degrees Fahrenheit. And in fact, like if you look at things like this, like the boiler makeup water, we've put that at 230 degrees roughly, something like that. And that's where deaerators usually run, which is around 5 to 7 pounds of steam, 5 to 7 psi. And so you can actually if you're bringing in this water from a river and it's 45 degrees, you can actually stick quite a bit of heat, stuff it in there to that pound of water prior to being 227 degrees. So really you could serve a bunch of that load, at a lower temperature as well. So anyway, these are the temperature profiles we picked for this facility. We've took 25% of the natural gas use that we have at the facility and said, all right, we can serve that with something that's a lower temperature. Now, because we've been able to look at kind of this heat stack analysis and we see at what temperatures we have different heat sources and how much on an annual basis in terms of million BTUs we've got, kind of figure out that, all right, now we can capture some of this waste heat and stick it into these mass flows that we have coming into the facility to essentially preheat them before they hit the process and our boiler steam. So by doing that, this facility, it works out to around 18% of the total energy of the gas use we can just get rid of, because we can capture waste heat from the facility and use that to preheat lower temperature things and stop using 18% of the steam at the facility, or natural gas at the facility just off the bat. The other thing we've done now, because we've looked at this as more of an optimized way, is that we can see we still have some green here that we need to heat. Looks like here's some drier air. And we can do that with lower temperatures because that needs to be about 170 degrees, 160 degrees, it looks like. Now we can look at these options. Which ones are renewable? Which ones have the lowest greenhouse gas emissions? And which ones have the lowest cost? And now we're playing in these options down here to try and get at that. Now we still haven't captured, 75% of the energy in the facility is still boiler steam, so we still have to tackle that. But we've done quite a bit of good for ourselves, and we can get a lot of this done in a way that saves us money as opposed to costing money. So if you want to replace your natural gas use at the facility for the remaining 75%, now you might be looking at something like renewable natural gas, which in pretty much all cases is going to 2-3x or more your spend on natural gas on a per million BTU basis if you want the renewable version of that. Now, again, we have opportunities like forest industry residues and things like that we can look at that can possibly save us money and be more of a silver bullet for us. But this general approach is one that we think is important if you're really going to try and decarbonize in a way that's cost effective for your facility. And I'm going to spend more time talking about temperature. So it might become ad nauseum for folks, but I kind of enjoy talking about it. So we're going to talk about temperatures more and further, and why it's really valuable on a technology basis, by decarbonization technology, why it's valuable to have lower temperatures. So a nice one, and this is energy efficiency, people have been doing this for a long time, is condensing boilers. And you can condense other exhausts as well. So we think it's really great to go in and get like dryer exhausts and things with lots of latent heat in them and get that latent heat pulled out and stuff that into energy mass flows that are coming into the facility somewhere. But this is a good example. So condensing boiler, this is from ASHRAE, very standard for commercial boiler systems and also industrial if you have a heat source or heat use. But you need to get the flue gas below the dew point of what it is in the flue gas, and so that you can condense out the steam and capture that energy that's in the latent version. So that's what a condensing boiler does. If you can't send 120-degree water or cooler back to this condensing boiler, you don't have a condensing boiler. You are now in a conventional boiler space. Like we have a pet peeve where we go into these commercial buildings and they say they have a condensing boiler that's 92% efficient, but it runs at 180 degrees, and we have to tell them, no, that is a conventional boiler. It is not a condensing boiler. So this is, you can clearly see why you need to drive your temperatures down if you want to use this technology. And you can do this, like I said, in other exhausts, and that can be pretty powerful for a facility. It's all about the temperature. When you hear electrification discussed, mostly the beneficial version of that, a lot of times right now, and it depends on your grid and a lot of things, but a lot of times the way that the project people are really trying to do, they mean industrial heat pump, because we can pull heat from we can take really low grade heat and lots of it from one place. We can use a little bit of electricity, and now we can offset quite a bit of thermal energy in our facility. So here's an example and some curves showing why temperature matters to this process for an industrial heat pump. And this is at a facility where we have waste heat rejected at 90 degrees, and we want to use it to heat, in this case, a greenhouse. So here's our efficiency or coefficient of performance by temperature. As temperature is increasing, that goes up for this machine. And we're putting in electricity to drive this thing, so we have to pay for that. And here's the dollars per million BTU of heat delivered to the facility that we spend in electricity to get that done. So you can see, I can't remember if it was this one or not, one of the greenhouses we worked at, they started out and they wanted to use steam to heat this facility, which is no problem. You can do that, but in a new facility, you might not want to do that. And so we suggested hot water. So we started hot water at 180 degrees. And then we said, well, can we design this facility that needs 78 degrees inside of it? That's what our goal is. We need to hit that, to use something other than 180 degrees to heat air up to 78 degrees. And the answer is yes, we can do that. And it changes the design of the HVAC system for the facility a little bit. But look at the benefits. If we can get 120 degree temperature, is what we're using in our heat exchangers to heat air to 78 degrees, that means our cost of energy is around $3 per million BTU with this heat pump system. If we need to use 150 for whatever reason, which maybe is a constraint, now we're at $5 per million BTU. So you can see pretty quickly, only in 30 degrees of temperature of supply, we've changed the effectiveness of this heat pump system in a pretty large way for serving this facility. So again, the temperature is critical. Our company does a lot of combined heat and power work, and I'm going to talk a little bit about that now. So if this slide's kind of confusing, and I apologize for that, I'm just going to make some basic points off of it. So the first one is that if you hire our company, we will almost invariably try and get you to do a thermally led combined heat and power project. And what I mean by that is we look at the heat energy that's going to come out of the prime mover, and we try and size the prime mover based on that heat energy as opposed to your electrical demand. And the reason is we don't want to send any heat to the atmosphere that we don't have to, because that's valuable and useful to us. So our best economics on a CHP system are if it's thermally led and we're leveraging all that heat, and then whatever electricity we get out of it, we get out of it in a very efficient way that's cost effective and helps your facility. That is all temperature dependent. So if you look at a combined heat and power system that's a gas engine, for instance, the temperature that you can get, let's say you want 100 psi steam, so that's like 340 degrees or so. The portion of energy of the thermal energy that comes out of that gas engine that you can capture is maybe 15% or so if you require us to give you 100 psi steam. If you said, but I can do all this heating over here, preheating of things with 150 degree water, we can then give you 70 to 80% of the thermal energy available from this engine. And it's a much more efficient system overall. So again, it's really temperature dependent, kind of the viability of your CHP system. And that's not the only consideration. There's lots of CHP we've done where we have to dump some heat. I'm not gonna tell you we don't, but we're certainly trying not to very hard with how we set those systems up. One more thing I want to mention kind of on I've started to shift between scope 1 and scope 2 a little bit here because we're doing some electrification where we're taking, with that industrial heat pump, where we're taking thermal energy out of the facility, so that's reducing scope 1 emissions, but we're using a little bit of electricity, so we're increasing scope 2. Talked about CHP. Another one that kind of bridges that gap or spans that is thermal chillers. And these have been used in industry for a very, very long time. Usually you see them where you have high quality thermal energy that's wasted, and you have some fairly expensive electricity and some cooling demand. And that can make them extremely valuable to facilities. And there's other reasons to use them too for lots of other reasons. But what's changed in the last 5 years or so is that you can really use some pretty low temperatures to drive quite a bit of commercially available equipment to provide this cooling. So with 185 degrees as an exhaust stream or a waste stream, you can do some pretty good cooling of something in your facility. And the scale that's available now is more broad, I think, than it used to be. So you can go down as low as 10 tons and you can go as large as you want. But you can now use lower temperature energy that's a waste and really drive a cooling process to help reduce scope 2 emissions at your facility. So I started to dip into scope 2 a little bit from scope 1. Just going to touch on this briefly, and clearly it's very important because a lot of facilities and many facilities, greenhouse gas emissions from scope 2 from your electric purchases are the bulk of your greenhouse gas emissions. So clearly very important. One thing I would say is that at most facilities, whether they've done efficiency or not, there are more energy efficiency projects you can do. The real question is, are they economically viable? And so that's really the threshold that usually tips what efficiency projects you can actually do versus which ones you can't. The other thing I'll say is that now's a good opportunity to start to seek chances to capture waste heat and do waste heat to power. There's a new tax credit that's available that's making that more economically competitive. So if you have particularly high temperature waste heat, you can capture that, make power. And if you can segment out some lower temperature needs, you can also take the energy out of that prime mover that you've stuck in that was waste and that's lower quality now coming out, and maybe offset some of that scope 1 emissions as well with that. But the reason I focus less on scope 2 emissions overall is that increasingly you have an option for market-based ways to drop your scope 2 emissions. So depending on the state you're in and which utility you have, it can be somewhat easier or not as easy to come up with a market solution for that. And in a lot of states, we're seeing fairly cost competitive electricity that you can tie through contracts to be renewable. The one thing you have to watch out for with that is that if you look at the greenhouse gas protocol and how the accounting works and the discussions in the accounting world, you have to report on a market basis if you want to do that, as well as a location basis. And so you can kind of infer that the reason for that is if you're buying some cheap hydro from somewhere in the country through contracts, but you're in a grid that uses a lot of coal still, at some point in time, it might catch up with you. Currently, the contracts take care of it, and the market-based solution really works for folks. And so that's why I spent less time on this, is that the grid is becoming greener over time, and there's a lot of government subsidy already focused on this and policy focused on getting the grid greener. So hopefully that happens over time, and it's one less thing for an industrial facility to have to worry about. Final thing I want to do is just talk about a couple, I don't want to call them tips, but thoughts we have about how to look at decarbonization projects. And if you think it's a useful approach, you can kind of copy that, or you can throw it away if it's not good. But one thing that we like to do is really track things by, we like to make metrics that get at what we're actually trying to do. That sounds simple, but we don't see it all that often. We would suggest, if you're trying to decarbonize, look at metrics such as dollars per ton of greenhouse gas avoided by a project you're doing, and we would suggest doing that on a life cycle basis for the project or for the equipment that you're installing. So the best projects are going to be ones that over their life pay for themselves and provide a return, as well as reduce greenhouse gas emissions. Those are going to have a negative cost per ton of carbon avoided. Ones where you actually have to pay more money because you use the equipment over time, those are going to have a positive cost per ton, and it'll help you stack up projects against each other. Another kind of thing is ways to think about financing and financing considerations. One thing that's always fascinated me is the kind of the risk versus reward for energy projects. So when we go into a lot of facilities, they have a capital pool that the facility is playing with, and they have to figure out how they want to spend that. And no matter what the project is, whether it's a new line for making widgets or whether it's an energy project, the ROI, and it's a 2-year payback. Give us a 2-year payback or we can't do it, which is fair. And there's a lot of reasons for that and for managing capital that way. But that really kills a lot of energy projects that really don't have the same risk profile as a new line of widgets. Energy projects, a lot of them you can define pretty well what the risks are. And if you align the return or the reward associated with that risk, you're going to look at financing that, you don't really need, an ROI that results in a 2-year payback. So that's just something to think about. There's also financing mechanisms that may help you with that. And if you look at like PACE commercial in some states, or lease purchase, or other ways you can tie capital repayment to the facility or the asset, that can help generate positive cash flows from some of these energy projects, which can really help you. Another thing that it's been around for quite a while, but is really coming into, I guess, vogue now, is energy as a service. And this is a really good opportunity for a lot of facilities who want to decarbonize, but really have pretty tight capital requirements. Essentially what this is entities who are backed by or have their own cash, who want to make money, want to do something with it other than the stock market probably, and want to leverage your expenditure of energy to make money on their money. And so they'll do an energy project for you or help you decarbonize, and you will pay them a fee over time to recoup that money plus their return on their investment. And there are many reasons to use this model, and it is a very good model for getting decarbonization projects done. In fact, we would offer that. We can offer that model as well. But the one thing we like to tell people is you have to be aware that you're paying someone a premium to do what you could do yourself. And so everybody, as long as everybody acknowledges that going in, and everybody knows that's what we're doing, it's a really good model. And there's a lot of reasons you might want to do that because of the expertise of your partner, those types of things. There's a lot of reasons. The final thing is incentives. There's many out there. Again, get into them because we don't really know what projects you're looking at exactly, and they vary by project. But certainly you want to be exploring what incentives are available and talking to your state representatives and other folks who are out there trying to promote these incentives anyway. They're looking to help you with your project and make it happen. So that's the end of my presentation. I'll just do a quick summary. Overall, I didn't have time to really dive into a lot of the pieces like the reporting and the goal setting and various things. But you could spend hours on different segments of this. But hopefully we hit some key ones that give you some ideas on how to at least think about perhaps approaches that might work for you or not for decarbonizing scope 1 and maybe a little bit of scope 2. Some of the key takeaways I'd like you to have are, there are opportunities we find where it's almost like a silver bullet. You can save money and decarbonize, and it's great. That's somewhat rare, and usually what's going to happen is you're going to go through your iterative process and you're going to find 3 projects this year. I really like those projects. We're going to make those happen. All right, yes, and we're going to do these projects next year, and we're going to do these projects next year, and now we've reduced our carbon emissions, scope 1 emissions by 25%. And so it's going to be a process. The other takeaway I'd like you to have is that often it does require kind of a change in how you think about processes at a facility and as an organization. Couple examples of this would be how you manage data and how you actually leverage data and collect it. Another one is temperatures. If you're in an industry that is heating a lot of incoming mass flow like air or water, but you're using high temperatures, there's probably opportunities to use lower temperatures, and that lets you decarbonize for less money. And finally, there's a couple metrics that you might want to consider using, but really ones that really get at what you're trying to do. And then we do think it is valuable to look at how you finance energy and decarbonization projects and maybe put that in a different bucket if possible. Not always possible, from your other capital requirements or other capital spends that you might have that have pretty tight ROIs required for them. So that's the end of my presentation, and I'd be happy to stick around and take any comments.
Sorry about that. Thank you so much, Dan. We do have a couple of questions in the chat from Laura Combs. The first question is, how much renewables are installed versus purchased from the grid for industrial facilities? And if purchase is preferred over install, and why?
Okay, so I would say mostly purchased, less installed, and the reason is there's only so many things you can do in terms of installed at the facility. Now, it depends on the industry and it depends on what you're doing. So if you're doing a bioenergy project that has significant combined heat and power, there are a lot of opportunities to make your own power in a renewable way. If you're doing solar, you have to have the land to make it work. And those are, 2 of your bigger opportunities for renewable generation on site. So if you're an industrial facility that uses a lot of electricity, but you only have your building and maybe a parking lot, your ability to do on-site solar is somewhat limited in terms of space. So it's a little bit easier to just buy the energy and so I would say tends to be more market-based purchases. You need to check with your ESG folks and make sure that you're okay with that. And most people are totally okay with that at this point. It's not a problem. So I would say definitely purchased in.
Okay, and a follow-up question from Laura. What is a preferred payback period for solar install, and is PACE utilized much by the industry?
Preferred payback is whatever you put on it for your facility. I think you need to establish that for your money and what you're willing to accept, and then push all your energy projects have to stack up against what your corporate entity is willing to accept for decarbonization. Often the first question we ask clients is that question directly, what is the payback you need on an energy project to make it go? If it's a decarbonization project, how do you view that, and what is the requirement? And that is a big driver for what options we can stop talking about now versus what we might start to keep looking at. And it's the metric by which all your projects are going to be stacked up against in the end. And I apologize, I forgot the second portion of the question.
About PACE being utilized much by the industry.
Yeah, PACE is great for that. You're going to tie the investment to the facility, and the taxing entity, essentially it's a loan.
Okay, Laura, I hope we answered your questions there. Does anyone else have a question for Dan today? You can unmute, you can drop it in the chat, however you want to communicate. Laura says, we rock. One more. Are there general IRR and NPV thresholds?
Again, like, that's something you need to establish yourself. But I would, when we push people on that, because if your goal is really to decarbonize and you're not going to fund it, you're sticking the facility managers with in a rock and another rock on top of them. There's no it's kind of a difficult challenge. So a couple of ways to do that are, segment out money that you're going to dedicate towards is one thing. But if you can set up a pool that's going to set up reasonable requirements for ROI for getting decarbonization projects done, it's good. At some point in time, and there's lots of facilities that are doing this, they're paying more money annually. They're not saving money. They're not getting an ROI. There's no IRR. We pay more money, we get carbon reductions, and that's where a number of facilities are. And that's not where you want to be, but I know, but that is happening. And so doing it with some kind of return in a way, for as much of it as you can, is really a good step, because it is going to take you a while to do the projects too. I mean, you're not doing this in 1 year.
Fantastic. Anybody else with a question? Okay. Well, with that, we'll go ahead and conclude today's webinar. I will attach a copy of Dan's presentation today in the follow-up email. It does have his contact information if you think of any other questions you may have for Dan later on in the day. Just a brief reminder that our next webinar event is coming up on February 22nd, again from 11 to noon Eastern Standard Time, on reducing carbon footprint. Otherwise, whoops, sorry, we've got another question popped in here. Charlie Martin asks, what are the key metrics you use in persuading clients to recognize that energy products are lower risk? Good question.
That's a great question. That's a good question on metrics. I'm not sure I thought about it that way. I'm sure we've used them. I'd have to go back and look. But in the end, if you talk to folks and you look at, let's take like that compressor for compressed air, and you're controlling your compressed air a little differently, and now you have VFDs on that. That's pretty well established efficiency project. It's you can put some bounds on, like, let's say it doesn't perform quite as we said it would. Let's say it's 50% worse than we thought in terms of performance. You can see how that varies the payback period pretty easily. And maybe this isn't the best example, but this is just an example of how you can kind of look at what are the things that could really mess up our estimate of the ROI or the payback, and do a little sensitivity on that. And it's pretty easy to see what the impacts that are. And you can look and see if energy prices change completely. What does that do? So I would say, off the top of my head, I don't remember what metrics we would usually use. Often we'll use this approach where we've got a sensitivity analysis. So we have a table that stacks up, two metrics we're trying to compare against. Say one's natural gas price for a project, and one is efficiency of the system or something like that. And you'll see how the savings vary as those two metrics vary, because they're the most important ones that you pick to choose how you want to analyze the risk, and you can assess that. And so I guess we're not a giant company, so we've never spent a lot of time on risk management as a thing. We'd like to just kind of assess it and understand it, and we've identified it. But that's how we usually do it, is we would do it on let's vary the variables a little bit and see how things get messed up and see what the possibilities are.
Great question. Fantastic. Anyone else with a question? I know it takes a moment to type them out if you're typing them in the chat, so I don't want to cut it off too short. Okay. Well, if there are no other questions, then we'll go ahead and close out for today. Again, Dan's presentation will be available to you through email with his contact information if you do think of other questions. Otherwise, Dan, thank you so much for your time today. Lots of great information. I hope everyone found it useful. And from all of us here at the center, we hope everybody has a great rest of your day.